welcome to the existing members of this channel. Welcome to the new members. So if you are new here, my name is Insika Abasi Imedugo. I'm the founder of this channel, Educate. So in this channel, we usually solve and discuss about topics related to our different courses in engineering, which include Math 122, physics and statistics. So vectors, we also discuss vectors here. So stay tuned for upcoming videos. And we also discuss other students related matters like how to study effectively for exams. So stay tuned for upcoming videos. Alright, right now we are given a question on vectors which says that given that R is equals to A, I plus B, J plus CK, we have to determine the direction cosines of R and direction ratios of R. First of all, starting with this question, you have to draw the diagram relating each of those unit vectors. Here is the diagram. So this is the 3D system representing the X, Y, O and Z, O and P and Z axis. So now this is the unit vector OP. So the angle that meets with vector OP is going to be alpha, and the angle that meets with vector OY is going to be, when OP meets with vector OY is going to be, they will form a beta angle. This is beta, and when OP meets with vector Z with vector OZ is going to form a gamma angle. Contrary to what I said, so when OP meets with the y-axis, it forms beta angle. So when it meets with the z-axis, it forms the gamma angle, and when OP meets with the x-axis, it forms alpha angle. So one thing important here is that all of them are moving anti-clockwise. So now the vector A, B, the vector angles alpha, beta and gamma are known as the direction angles, and when you add a cos sign to them, it will now be the direction, it will now change to the direction cosine. The vector, so the direction cosines are given by cos alpha, which is always equals to L, cos beta is always equals to M, and cos gamma is always equals to N. So cos alpha is always equals to A all over the modulus of R. Cos beta is B, the OX, the OP, OY, B, which is B, all over the modulus of R, and cos gamma is always C all over the modulus of R. So recall that R is equals to AI plus BJ plus CK. Modulus of R is equals to square root of A squared plus B squared plus C squared. Properties of determinants. This is always the formula for modulus of any vector. This is it, square root of those unit vectors. Unit vectors are the coefficients of I, j, and k. So you add once you square them, you add them like the way I'm doing here. You get it. So now from there we substitute in the values for this cos alpha. Note that this was R modulus was not equals to square root of a square plus b square plus c square. It was equals to plus or minus square root of a square plus b square. Because if you take the square root of any number, it's always plus or minus. Square root of 4 is plus or minus 2. So that's why when we substitute in the value for R modulus, we have this, because R modulus was equals to a square, square root of a square plus b square plus c square. And so cos, if you take the cosine of the angle alpha, you have plus or minus a square, a all over. So after substituting in the value, this is what we have as our answer for the direction of cosines. So we are done with number 1i. Direction ratios are, you have to find the direction ratios. Direction ratios are the coefficients of the unit vectors in the expression of the vector in Cartesian coordinates. So we write it down as our answer that the direction ratios are the coefficients that appear in front of the unit vector I, j, and k in the expression of the Cartesian coordinates, which are a, b, and c. There are these coefficients a, b, and c that appear in front of the unit vectors. So we've reached the end of our study session. You can screenshot it. This is the number 1 answer. Number 2 answer to number 2 question will be coming out in my upcoming video. So stay tuned for more. And also I will be posting questions on math, vectors, physics, and statistics. So you can consider subscribing for future updates. You can consider subscribing to my channel if you are new here. Thanks for watching. Click the like button for the YouTube algorithm to share my video across and for me to get more views. If you found this video helpful,